and M1. Okay, so I'll just move on to the classroom since again, this entire concepts of maths will have a lot of worksheets and formulas and books involved. So we have a classroom generated for the AS Physics or AS Maths, and I have already uploaded the introduction for the chapter one. These are the book provided by the Pearson. Okay, these are the two books provided by the Pearson. We are going to start with like this trial class. We are going to explain maths from Pure Maths 1 book. Okay. And with addition to this, actually, we also need to solve some extra worksheets because I don't know how long it will take to open this book. So the first chapter is very easy if you follow from the book. The book actually has maybe one A, B, C, D, E, F, like six sections for the chapter one, and contains very easy and basic maths. So what I will do is that we'll follow the book and also a worksheet. The worksheets are a compile of questions from the question papers. Okay. If I go back to this section, now, this is the worksheet for the chapter one. Now, these are all the questions taken from the question paper, and they only contain concepts about your chapter one. After we are done explaining all the sections of chapter one from the book, we will solve these worksheets. Mainly, this worksheet will be entirely a homework, and we will have a problem solving class of this homework in our daily classes. Okay. So we'll start with the chapter one. Okay, before that, again, since we're doing maths, so obviously formulas are related, and we have to provide formulas for every chapter. Now, the book also provides formulas at the top of every section. Like before starting one A, they will give an example and formula needed to solve one A maths. But I think that's quite tough for you to collect all the formulas from different sections of the book. So this is a compilation of every formulas or every kind of methods that are involved in the working for chapter 1 for the P1. Okay, this is not for the P2, this is just for the formula booklet for the chapter 1 of P1. Okay, so every time we start a new chapter, I'll upload a new set of formulas for that specific chapter. So let's just first get introduced with the set of 14 equations that are involved over here. So 14, 15, 16, 17. I think the formula for the middle term is not new for everyone. So we'll first introduce the other 17 equations and then move to questions from chapter 1. Now, all the PDF notes, all the worksheets, all the formula booklets, everything will be uploaded in the classroom, and I will solve the maths in this S Note file. Okay, so this will be uploaded again in the classroom under the heading of maybe P1 chapter 1 slide 1. Okay, so you guys will also get these sections, these files in the classroom. I'll upload this after the end of every class. Another thing that all our classes will be recorded. So in case if we are dealing with some difficult topic, which is mainly M1 and P2, like some chapters of M1 and P2 are quite difficult to understand. So I would expect, since we are providing recordings for every section, every classes, I would expect that all of you to finish the class and after the class, go through the entire recording once again for the tough topics or difficult topics so that you get the entire idea and entire concept of those difficult concepts at a very deeper version and as clear as possible. So this is P1. P1. Okay, so over here, a power m. In this section, I specifically use this template because so that I can represent that where the power should be and the base should. I know we have already did all this working in our IGCSE's part. This is the base version, and over here m is the power. So the first example is for the multiplication. When a power m multiplied with a power n. The bases are same, but powers are different. So you don't need to multiply this in a similar, like in a usual traditional way. You can easily take the power common, so base common, and in case for the multiplication, when the bases are multiplied, the powers will be added together, m plus n. This is the usual case. You can also go to the reverse way. For example, in some cases, the equation might be 2x plus 1. What does this represent? It represents that the bases of this 2x and 1 were both 2 and they have been a multiplied format. That's why the powers get added to each other. So you can break this down and write it like 2x multiplied with 2 power 1. So you can go in either way, forward direction, backward direction, both are correct. So you can further write this down as 2 power 1 only represents 2. So you can write 2 power 2x, right? So this is an example for the summation of power. This is the first formula that will be a very important part for the calculations of chapter 1 class. Let's move to part 2. In this part, we are going to work with minus. That will be exactly the opposite of the plus working. For the plus working, the bases were supposed to be multiplied with each other. This time, the bases are supposed to be in a divided fraction. So over here, whenever the bases are divided, also the base always has to be same. If the equation is like this, b power n, then you cannot do anything over here. The bases have to be of the same unit or same amount. So now you can take the base common and the powers will be in a fraction format. Similarly, as an example for this formula would be 3 power 3x minus 2. As the powers have a minus within them, it represents that 3 power 3x was divided with the 3 power 2. The second one always becomes the denominator. This is the denominator and this is the numerator. Right? For multiplication, the order was not a matter. For division, the order always is a very important fact. If you wrote this like this, 3 power 2 divided by 3 power 3x, it's not the same. Over here, you have to specifically write 3 power x at the front and 3 power 2 at the back because the second number of the power becomes the denominator and the first number of the power becomes the numerator. Right, if I go back to the formula sheet, we are done with the first point. Okay, we're done with the first two. The second one over here represents that a power m with the power of n. Whenever we have a power inside a power, this time the powers gets multiplied. Okay, now it becomes a power mn. You can see the example when we have x power 5 with a power of whole square, the powers gets multiplied with each other and you end up with x power 10. And if you have a power for any multiple numbers as a whole, then power is a part for both the numbers inside the bracket. Over here, the n power was on top of both a and b. So that's why you can break this down and write it separately as a power n and b power n. Similar case for the fractions and everything. These are the same part in multiplied format, in fraction format. Okay. Moving to equation 7, a power minus 1. Whenever you have a minus power, it always indicates that it originally belonged to the denominator of a fraction. So that's why you can write 1 divided by a power n. There's actually a typing mistake. It's supposed to be a power n. Okay. Uh, Moving to the equation 8 over here. I'll just write the equation 8 in this part. B power minus n. Again, introducing a very basic format of fraction. that I think Yuki just already saw in the previous class. Uh, A by B divided by C by D. In this section, this is the numerator and this is the denominator. Okay. So over here, you can actually write the numerator separately as A divided by B. Whenever the denominator is itself in a divided format, it gets inverted and then multiplies with the numerator. So when the denominator gets like inverted, it now looks like D over C. Originally it was C over D, now it is D over C. So now you can easily multiply AD over BC. Similar case is a rule over here. As we have already seen that a power minus n represents 1 over a power n. So we can write this down as a power minus n as 1 over a power n at the numerator. And again, b also has a power of negative n. So it will be 1 over b power n, which can be further written down as 1 over a power n multiplied with b power n divided by 1. Finally, you end up with b power n over a power n. Is there any problem for this eighth formula?
No, Apu.
Okay. Then we'll move to the second working. The second working is where introduction of group signs. For example, if you have x power 2 is equals to 5, then when you are shifting this square to the other hand side, it becomes actually half. Okay. It becomes 1 by 2. And for these fraction powers, you have a different sign. That sign is known as the root of 5. Now, half is always the base format of root. In cases of base format, you don't need to write 2 over here, okay? But if the situation was different, for example, if it was x power 4 equals to 5, then in this situation, obviously the equation would be 5 with the power of 1 over 4. And again, as we have a fraction power, this time we'll have a root. 4 is not a base root. So you'll have 4 root over here. So you need to write 4 in this section. Right. Similarly, if you have anything as a power, for example, a power n equals to 5, then when you are shifting this n to the other hand side, becomes root n 5. Right. Only if the value for n is 2, then there's no need to write n2 over at this section. But if the value of the power is greater than 2, maybe 1 by 3, 1 by 4, 1 by 5, 1 by 6, whatever the value is, you are always supposed to write that number at the top of that root sign. Lastly, the equations of the whole square. A plus b whole square. Okay. In this section, you actually break this down like this. A square plus 2ab plus b square, which eventually gives you a square plus 2ab plus b square. Lastly, for a minus b whole square, you get, again doing the same working. But this time the value of b was not positive. This time the value of b would be minus b. So you have minus b over here and again minus b square. If you do the calculation and simplify this term, it looks like a square minus 2ab plus b square. So when you are actually memorizing the formulas doesn't have any difference. The two formulas become different because of the side of b. In one case, the b was positive, making 2ab plus. In the other case, the b was negative, making this 2ab minus. Right? So is the value of b or sign of b. The formula is same for both the whole square concept. Any question for these two formats?
No, miss.
So we'll move to the next part, a minus b and a plus b. So when you are multiplying this, just take it like this, that a is multiplied to a plus b, and then minus b is multiplied to a plus b. You're taking this a and multiplying it to a plus b, and then you're taking minus b and multiplying it to a plus b. So when you're multiplying these values, you get a square plus ab, and on the other hand, you get minus ab and minus b square. These values of ab get cancelled out, and you're left with a square minus b square. So again, you can go at both direction, forward and at backward. So which means that over here, you can finally write, there's no point of writing a square over here separately. A square minus b square gives you a minus b and a plus b. Okay, so now we'll move to the calculations for the chapter 1. So we'll start with 1A, but I'll start explaining with exercise 2. Exercise 1 is quite very easy. For example, for the R question over here, they want you to multiply 3a power 4 with 2a power 5 and a power 3. So you can just multiply the numbers together, which is 3 into 2 becomes 6. And when you're multiplying a power 4, a power 5, a power 3, that means that the bases are same, powers are different, and bases are getting multiplied. So you need to add all the powers. So the final power would be 5 plus 3 is 8, 8 plus 4 is 12. So it becomes 6a power 12. If the overall working is not clear, I'd still do the work over here. For 1R, the question was 3a power 4 multiplied with 2a power 5 and a power 3. You can just separate the numbers from the alphabets. Right? This is the final answer. No need to extend this maths and do it in such detail. I did this for the sake of explanation, but other than that, you can just quickly jump to the fourth line directly to the answer, and that will be fine. So I'm actually moving to exercise 2. We're not really doing any maths from exercise 1 because it's quite easy over here. Okay, let's do another maths from exercise 1. The d4y cube whole cube divided by 2y cube. Okay, last maths from exercise 1. 4y cube with a whole cube, and this gets divided with 2y cube. So you can obviously write this in fractions, easier for you to understand. So since you have whole cube on both 4y cube, it indicates that you have 4 cube y power 9, right? Because when there's a power on top of power, the powers get multiplied with each other. So 3 into 3, you get 9. And at the denominator, you have 2y cube. When you're doing the calculation of 4y cube, it becomes 64. So you can subtract this, divide this. When you divide 64 by 2, you get 32, right? So you have 32 in this part. So 32. Another thing that the y's over here are divided with each other with different powers. So obviously the power will be subtracted. So now you're left with 32 y power 6. I know very easy maths to work with. So is there still any question from exercise 1, R and T?
No, Apo.
So we'll move to exercise 2 quickly. I'll do give you some classworks, but not from these easy exercises. Okay, so we'll move to question 2b. 3x squared, 2x plus 1 and minus 5x squared, 3x minus 4. Okay, so when you multiply 3x squared with 2x plus 1, you get 6x cubed plus 3x squared. And when you multiply 5x squared with 3x, you get 15x cubed and plus 20x squared. Now you need to just find out that which are the same units or same quantities. For example, these are the same quantities since they both have x cube as the coefficient, and these are the same quantities as they both have x square as the coefficient. So when you add the values, 6 minus 15 is minus 9x cube, and 20 plus 3 is 23x squared. 23x squared minus 9x cube. No need to take x squared as common between these two. We're supposed to simplify the answer, so that's up to this level. No need to take common and make it much more trickier. So just keep your answer up in this part. So we're moving to other parts of the section. We'll do the calculations for question 3, okay? Other than that, all the questions from question 2 are quite easy again. Yeah, so we'll just move to question 3. Question 3, part E, I think that's quite tricky. 7x power 7 plus 5x power 2 divided by 5x. Now in this time, over here, the denominator only have 5x, right? It also indicates that both 7x power 7 is divided by 5x, and lastly, this 5x square was also divided by 5x. Now, the only x represents it has a power of 1, so you can write 7 over 5 x 7 minus 1. The powers get subtracted because they are divided. And on the other hand, 5 can be cancelled by 5. And the final sign would be 2 minus 1 for the power. It will be x with the power of 2 minus 1. So you can finally write this down as x power of 7 over 5 with x power of 6 and plus x. Any problem for question 3E?
No, Apu.
Okay, then there's a quick classwork for both of you. Please try to solve question 2U and 3F. Question 2U and 3F. So please do this maths, show your working to me in WhatsApp or Messenger.
Done, miss.
Okay, then can you please send me the picture of your working in WhatsApp?
Okay. Miss, I have just sent the photo.
Yeah, check. I received your picture. শিমুলা তোমার ম্যাথস পুরোটা ঠিক, তুমি তো ইকুয়ালস টু নাই সাইডে, ইকুয়ালস টু না দিলে ম্যাথসে মার্ক কাটবে। আই নো সিলি, বাট তোমার এ লেভেল যেটার জন্য মার্ক কাটে।
Okay, Miss.
হ্যাঁ, দুজনেরটাই ঠিক আছে। ওকে, so we'll move to the next topic. Right, there's nothing more to deal about with the 1A. I'm actually trying to explain this entire chapter 1 in today's class, so that because it's very easy. The only important sections are actually 1E and F, where we are working with the rationalization of roots and denominators. Okay, so we'll simply move to 1B, and I'll solve question 1R for you. 1R has 4y minus x minus 2 and 5 minus y. Again, it has the simple basics of the multiplications over here. We're still not even involved with the formulas that we have discussed at the beginning of our class. In this situation, we're supposed to multiply 4y with the entire 5 minus y, and again do the same parts for minus x and minus 2. So just write this down separately, that 4y, 5 minus y, minus x, 5 minus y, minus 2, 5 minus y. So you get 5 into 4, 20y minus 4y square minus 5x plus xy minus 10 plus 2y. Then again start identifying that which quantities are of equal. For example, there is no combination for y square. So you cannot add the y squares together, or there's no combination for xy or x. There's only one combination for 20y and 2y. So you can just write 22y minus 4y square minus um, xy minus 5x minus 10. It's always preferable that in this kind of situations, you start writing your answer as an alphabetical order, or as a power order or numerical order. For example, minus 4y squared was the biggest value for y with the maximum power. Then you can write 22y, then minus xy, minus 5x, minus 10. It's just more organized and arranged in this section, but you can also keep your answer in this format. Both are correct. Is there any question from 1R?
No, Apu.
Okay. Then we'll move to the second questions of this heading. Mhm. Yeah, the second one, again, only have our multiplications over here. But for the question number 2x minus 3y with the power of 3, this is actually a little tricky. You can obviously solve it with the formulas that we have provided. 2x minus 3y. Now this power 3 indicates that there were two, like 2x minus 3y multiplied together, right? So you can represent this like this, square, and this is again further multiplied with 2x minus 3y. So you can break down the front whole square in terms of a square minus 2ab plus b square, so which is 2x whole square plus 2x minus 3y plus minus 3y whole square, and further it is multiplied with 2x minus 3y. So this is 4x square, 4 3 minus 12y plus 9y square multiplied with 2x minus 3y. I'm obviously making this maths ridiculously big so that every step is in detailed format for you all to understand. But you can obviously skip this line over here that I'm writing down. Now again, there's a time to combine all the values where you can clearly see that there's no like pair of the other format. Like there's no pair of other x cubed, x squared x, or y squared, xy, right? So everything is new for this section. So um, there's no point of arranging it at all. And it is also arranged in chronological order or alphabetically order. So you can not arrange this in any format. So this is the final answer for this part. So move to question three, I guess. Question three was a word problem kind of stuff. And question three, four, and five are a combination of word problems. Now four and five are quite easy because if you focus on question five, we can see that they have already given you a set of equations. If you multiply all these three, they would actually resemble to this format, right? There's no point of focusing on this section, right hand side of the equation. Just focus on three terms. When you multiply this, then at the last, when you simplify all the values together, you clearly see that your answer is also in the same format. And you can just identify that what is the coefficient of x cubed, that will be the value for a. What is the coefficient for x squared y, that will be the value for b. Right? Similarly, you can just arrange this in that pattern. Okay. In that way, for the question four also, they have the dimensions of a cuboid and they want you to find out the volume. So they want you to show that the volume is so the volume is 4x square and this. Okay. Now, in terms of volume, we're supposed to multiply the three dimensions, right? Length, breadth into height. So again, when you multiply these three together, you would finally end up with this statement. So there's nothing different from the previous ones. It's just in a word problem manner. But for the question three over here, they've provided a diagram which shows a rectangle with a square cutout, which means that the outside structure is a rectangle, and in between that there was a square structure which is removed from the rectangle now. The rectangle has the dimensions of 3x minus y plus 4 and 7 plus x, whereas the square, which obviously has equal four lengths, um, each of x minus 2. So they want you to find out the expand simplified expression for the area. For rectangle, the area is length into breadth, and for the square, the area is length square. Let me do the working for question three. It's length into breadth. The length was 3x minus y plus 4. It was multiplied with 7 plus x. So when you multiply these together, that is 3x squared plus 21x minus xy minus 7y and plus 4x plus 24. And simplified maybe. Yeah, simplification is possible. Like when we have 21x and 4x. So we can write 3x squared, 25x, then minus xy, then minus 7y, and lastly we have 24 over here. Okay, this was the area for the rectangle. Now do the same calculation for square. It would be length square. The length of the square was x minus 2. So we have x minus 2 whole square. And you get, if you follow the formula, you're supposed to get x square minus 4x plus 4. So since we have removed the square from the rectangle, so the total area of the rectangle will be subtracted uh, with the value of square, right? So the leftover area should be rectangle minus square. And rectangle is 3x square plus 25x minus xy minus 7y plus 24. This entire expression will be uh, in a minus format with x square minus 4x plus 4. So 3x squared plus 25x minus xy minus 7y plus 24, and this would be minus x squared plus 4x minus 4. The minus over here gets multiplied with everything at the back. So that's why it becomes minus x squared plus 4x and minus 4. And now you can make the pairs add together or subtract the pairs. For example, we have 3x squared and minus x squared. So the final sign would be 2x squared. Similarly, we have 25x and plus 4x. So you get 29x. We have 24 and minus 4, so it becomes 20. So we have minus xy minus 7y and plus 20. And this is the final expression for the area of the structure after we have removed a square from the rectangle shape. Is there any problem for this working?
No, Apu.
You can gain off the class. Then from the next class, the class is recording on থাকবে so that we can understand যে তোমার ম্যাথস গুলাতে আসলে কেউ করতেছে নাকি না। Also expressions দেখলে আমার জন্য easier হয় to understand that if you guys are actually understanding one concept. So can you all now please try to do question 5? And same process, you do the maths, take a picture, and send it to me in my WhatsApp or Messenger. think both of you if you do the maths quickly. কি প্রবলেম হচ্ছে কোনো এটাতে? পাঠাইছিল একটা মিনিট দাও। 2 plus 5 by 3 minus 2x plus 11 plus 6x squared minus 1 minus 15x squared minus 1 squared. Until 8 6 into 12x cubed. 6x squared by 4x squared by 4x squared 20x squared 15x squared minus 10x squared minus 1 cubed. For the 12x cubed, 1002x squared minus 3x squared. হ্যাঁ, রিলেটাই ঠিক আছে। These are quite easy maths to understand, right? আমি খুব efforts দিয়ে কিন্তু চ্যাপ্টার গুলো বুঝাচ্ছিলাম। তো we'll move to the second section of 1C. এখানে অনেক এক্সাম্পলস আছে। I would suggest যে তোমরা ফ্রি টাইমে পুরোটা পড়ো, go through this and try to understand every section. যেরকম একদম every পয়েন্টে লিখে লিখে দিছে common factors and everything. Just review করো। খুব ভালো ডেফিনেশনস দেওয়া আছে এখানে। আচ্ছা, এখন এখানে আছে যে আমি ফ্যাক্টরাইজ করব। Factorization and middle term এর একটা ডিফারেন্স আছে। The difference between factorization and middle term is that for factorization, you only need to understand how to take a common factor for all the quantities that are involved in your maths. For middle term, you have to split and then and then you have to do the factorization, right? So middle term factorizations are two different concepts. এখানে factorization চাইছে এখানে. So maybe in the next chapter, they are looking for middle term. Achha, now they're looking for negative power maths. So let's move to 1C. As for 1C here, question 1, u and x type to dekhi. 15y minus 20y z square. Okay. 1C, 1U. So it would be 15y minus 20y z square. Okay, in this section, we are first going to focus about the numbers over here. You have 15 and 20. Both is a product of 5, right? You can see these both numbers on the table of 5, which means that 5 is a common factor for both 20 and 15. So when you're supposed to take the common factor, you're supposed to write the common factor over at the front. And since this is a combination of alphabets also, now you go on focusing about the alphabets. So for both the terms, you have 1y, and for the 20 only, you have z squared. Since z square is not involved in the 15y, so you cannot take z as a common factor for over here. You can take y as a common factor. So you take y over here. So the numbers that should be inside the brackets, you find it like this. I'll do the rough work over here. We're supposed to divide every number with this common factor. So we have 15y. So divide 15y with the common factor, you get 3y. So over here inside the bracket, you will write 3y. Again with the minus sign, and you have to divide the common factor with the minus 20 over here also. So you get minus 20y z
আপু
square. বলো।
খালি 3
অনলি
হবে।
3 হবে।
কোয়েশ্চেনে 23 ছিল।
জি
না,
ম্যাম, এখানে
বললাম
3
কি
হবে।
যে অনলি 3 হবে।
ও আচ্ছা, হ্যাঁ হ্যাঁ হ্যাঁ, সরি। It will have only 3, so the y's gets cancelled out. Sorry. Okay, so in this part, again you can divide 20 over 5, so you get 4 minus 4. The y's gets cancelled out, and you get z square. So you get minus 4 z square, and the entire thing ends with a bracket. So So that's it for the factorization. That's how you take the common factor and do the calculation. Rough work is not needed. I just explained this for the explanation that how you're taking the common factor and input the values inside the bracket. So we'll move to the second part. For example, when we are moving with factorizations with three terms, this is exactly quadratic equations. And now you need to do middle term, like you need to split and then take common. Because when you have three numbers, three quantities, you possibly cannot take one common factor for all the three numbers. The first thing you're supposed to do is that let's start with the initial struct questions over here, which is 2b, 2x squared plus 6x. Now again, focus on the numbers. We have 2 and 6 over here. Both has a common factor of 2. So we can take 2 common. Whenever working with alphabets, for example, in this situation, we have x squared and x. Always take the alphabet with the smallest power as a factor, right? We will take x with the power of 1 or this x as a factor, not x squared. X squared indicates that it has two x's involved in that power. So obviously 6x doesn't have 2x, right? So always take the alphabet with the smallest power. So we'll take x common and in this section we'll have x plus 6, right? We're doing the same division format over here also. When you divide 2x squared over 2x, you get only x. And again, when you divide 6x over 2, you get 3. Great. Okay. Now for the two terms, it's quite easy to understand. Wait, my laptop screen, I think, just froze for a while. That's where it is. Okay, so we'll move to the next max, which is a combination of three numbers. Let me just introduce one format first. We'll do the calculation for n, 6x squared minus 8x minus 8. Over here, the equation is in a format of ax squared plus bx plus c, where a, b, c are obviously given into the equation. You can clearly see the value of a is 6, the value of b is minus 8, and the value of c is minus 8. Just give me a minute. I think there's some internet issue on my side. Yeah. So you can actually use your calculator to find the value of x1 and x2. Well, I'm not sure what calculators you both are using, but are we aware that how to do the calculations for x1 and x2? You can find out the roots of the equation using the calculator before actually solving the equation. I know Yuki can, but Niloy, can you please tell me that are you aware how to find out the value of x1 and x2 using calculator?
Yes, Miss, I know.
Okay, then please find out
Hello.
the value for x1 and x2.
Okay.
Okay, what is the value for x1 and x2?
Mm, x equals to 2 and x equals to 4 by 6.
4 by 6. In my calculator, maybe it was 2 by 3, right? Yeah, because you're supposed to, I mean, in your calculator, it will give you now simplified format. Wait, let me check.
Miss, you wanted me to do in calculator.
Yeah, I want, like, have you ever, how can you find the value for x1 and x2 in calculator? Like using the mode, shift, press,
Oh,
equation, find, like
yeah,
that.
I can do that one. Okay, okay, wait.
Yuki, तुम पूछ ले सकते, right? The process I'm talking about.
হ্যাঁ
Miss, the values are 2 and minus 2 by 3.
2 and minus 2 by 3. Okay. So now in order to do the calculation or factorization, I know you both already know the process, but just for the sake of explanation again, we are supposed to split the middle term over here. Then in the middle, we have minus 8x, right? So in order to split the minus 8x, we always take the coefficient of x squared, which is we're trying to split this, so we'll take the coefficient of x squared. The coefficient of x squared is usually referred to be the value of a, right? So the equation should be like this. I mean, 8 can be split into any combination 5, 3, 6, 2, 4, 4, 2, 6, right? Which one should be applicable for this scenario? Depends on the equation. So we'll do the calculation like this. A multiplied with the opposite of x1. Since you got plus 2 as a value for x1, so you're going to take the opposite value from your calculated value. You're going to take minus 2. So it will be 6 multiplied with minus 2, you get minus 12. And again, a multiplied with x2. x2 was positive, negative for your value, so we'll take positive value of that. So it will be 6, 2 over 3. If you calculate this, it's positive 4. So you're supposed to split that 8x, negative 8x, using 12 and 4 over here. So you put the values into the equation. It's 6x squared, 12x plus 4x minus 8. When you add the values, you can clearly see that they eventually add up to minus 8, which means that our splitting is correct. So we'll now take common. Now we have created a pair. The first two creates one pair and the second two creates one pair. So from the first pair, we can take 6x common and it will be x minus 2. And on the second pair, since we have minus or plus over here, so we'll take plus 2 common. So again, on the second pair, we'll have x minus 2. It's a written fact for the middle term that the common factors or the like the numbers inside the brackets should be same for both the pairs. Since our numbers inside the brackets are same for both the pairs, so our maths is correct. Lastly, you just need to connect these two as one term, which is it will like x 6x plus 2 and x minus 2. Good. So this is the final process. Now, if the question had given you an equation like this, maybe, wait, made a mistake. We're supposed to take 4 common, right? Okay. So if the question doesn't have any equals to 0, then you're supposed to end your working up to this. But the equation has 6x squared minus 8x minus 8 equals to 0, then you're supposed to find out the value for x. Okay, so which means that 6x plus 2 and x minus 2 would be equals to 0, indicating that 6x plus 2 is 0 and again x minus 2 is again equals to 0, which is, so this was 4. So we have 6x minus 4. So x is minus 4 over 6, which can be broken down and simplified in terms of 2 over 3. And lastly, on the other hand, you get x equals to 2. So these are the two values of x. And other than that, if the equation doesn't have any equals to 0 involved, then you can just input your, like complete your working up to this section. Now, for the previous working, these are the factors of the equation. Okay. And if you go back to this, where we have actually calculated the values of x, these are the roots of the equation. X minus x equals to minus 2 by 3 and x equals to 2 are the roots of the equation. So this will be a very important factor for our P2 classes. So just telling you in beforehand. Is there any problem on when to find out the roots and when to find out the factors?
No, Apu.
Okay, that's great. So we'll move to the question paper over here. Oh, factorize for the again question two, there is combination of other concepts also. For example, the question R, T, U, Q, P, even no, not V, okay. Just Q, R, S, T, U. Okay, these five questions are actually a combination of A square minus B square. For example, if I focus on the pen's question T, 9x square minus 25y square. 9 and 25 doesn't have any common factor. 9x square minus 25y square. 9 and 25 doesn't have any common factor. They also do not have share any common alphabet. So you possibly cannot take anything common between these two. In this section, you're supposed to turn the 9x square as a whole number, which means that you can convert like 9x square in terms of 3x whole square. And you can also write 25y square as 5y whole square, which can be further written as 3x. I mean, this is exactly in the format of that a square minus b square, which can be further descriptively written as a minus b product with a multiply with a plus b. So this is the same case over here. 3x is playing the role of a and 5y is playing the role of b. So you can write 3x minus 5y, 3x plus 5y. Is there any problem from question 2D?
No, Apu.
Thank God you turned off your music. So we'll move to question three. Question three doesn't actually have any different concepts. It's the same one. Um, Only difference is that now we have cubes involved with it. Now, cube doesn't have any important aspect over here. For example, if we focus on question 3a, that is x cubed plus 2x. You can just take x common and it will be x squared plus 2 and that's the end of the entire one. So you cannot possibly take anything other common between these two. Okay, now moving to a bit more trickier ones. I think I saw somewhere x cubed minus 4x. Yeah, h, x cubed minus 64x. In that part, you can obviously follow that a square minus b square, but you need to make that convert that x cubed to x square first. So it will be x cubed minus 64x. So if you take x common, it will be x square minus 64. Whenever you have the combinations of these square numbers, for example, you can clearly understand that 64 is a square number product, like 8 square, you get 64. So you can now break this down as x whole square minus 8 whole square, which is x minus 8, and x plus 8. Right? Again, for the last parts of this question 3, I think I'll explain L number. 3x cubed, 27x square, and 60x. So over here, since you can clearly see that all these three quantities have one x involved with it, and you cannot actually do middle term for this x cube expressions like this. So you're supposed to take x as a common, and you're left with 3x square, 27x plus 60. Now, the quantity of the equation inside the bracket exactly resembles your equation for the quadratic one, right? So you can just do the, using the calculator, you can find out the value for x1. which is x1 is minus 4 and x2 is minus 5. So in this section, you're not going to consider the value for x over here. We're only focusing into the equation inside the bracket. So over here, you're supposed to split 27x, and before 27, you have 3. So you're multiplying 3 with positive 4, which becomes 12, and 3 with positive 5, which becomes 15. When you add these two together, you actually get 27. So your splitting is correct. So you can write x, 3x squared, and 12x and 15x plus 60 inside a bracket. Then you start taking common from the first pair. So you have 3x as a common factor, so x plus 4, and plus 15 as a common factor, which is again x plus 4. Lastly, you can write x, 3x plus 15 and x plus 4. Is there any problem from the middle terms we did for exercise 1?
No, Apu.
Okay, so we'll move to the second parts. Okay, question 4 is not tricky, I would say, but a bit different. X power 4 minus y power 4. You can express power 4 in terms of square. X power 4 minus y power 4. So you can write x squared with the power of square and y squared with the power of square. This time, x squared itself is playing the role of a and y squared itself is playing the role of b. So you can write further x squared minus y squared with x squared plus y squared. Now again, this pair over here at the front is again playing a role of a square minus b square. So you can further break this down as x minus y, x plus y with x square plus y square. We cannot break down the positive ones, so we will just continue x square plus y square till the end of our working. Is there any question from this question board? Loy, you're not
No,
replying. Are
Apu.
you still in class or asleep?
No, miss, I'm still in class.
Okay, that's great. So we'll do a bit more maths and then we'll end the class for this. Um, we are done with 1C. Okay, if there's nothing else to explain 1C any further, so we'll just simply move to 1D. 1D has a little bit lengthier or tricky maths, I can say, because they have fractions involved, and this time with the power of negative values. Okay, for example, if you focus on question 1, K, L, it's quite tricky. And again, question 2, J, I, not I, J, L are tricky. So I'll just do a few maths from 1D also. From 1D, let's start with K. We have root x cube, cube root of x with the power of 4. Okay. Now we can represent root in terms of power, right? Root is just a sign for the fraction powers. So let's just write the powers, like express the roots in terms of fraction powers. So it becomes x power half, and it has a cube above that. And it gets multiplied with x power 1 by 3. It was a cube root of x, so the power is 1 by 3 and was again further has a power of 4. So whenever there's a power on top of a power, the powers gets multiplied with each other. So now you have 3 into half, which is x power 3 by 2 added with x power 3 by 4. Since you have the bases same and the bases are in multiply format, so the powers gets add together. So you have 3 over 2 plus 3 over 4. So you get 9 by 4, and lastly you can write x equals to 9 over 4. Now you can express your answer in this part. In some questions, they might ask you to write your answer as the format, like a root x b. Right? What does it indicate? That you are supposed to keep your answer in this format. So you can actually break your power. For example, 9 by 4 can be broken in terms of 1 by 4 into 9. So you can write x is 1 by 4 into 9. Powers are only multiplied when you have a power on top of another power. So you can write x 1 by 4 with a whole power of 9. 1 by 4 means this is a 4 root. So you can write root 4 with a power of 9 on top, which means that the value for A was 4 and the value for B was 9. Is there any question from this working? You can obviously keep your answer to this step, but in some question, usually in question paper, to make this maths a little tricky, they give you a format and you have to keep your answer in that exact format. So that's why you need to understand that how to take the fraction into the root format back again. Any questions for the question 1K?
No, Apu.
Okay, so we move to little, I think there was another maths which was tricky for question 1. L. Can you both try to do question 1L for me? Cube root x squared divided by root x. Remember that when the bases are in divided format, the powers get minus from each other. So you can keep your answer as x power 1 by 6 or 6 root x. Both are correct. Okay. So we move to question 2 over here. So for question 2, they want you to express the 27 power some fraction without using your calculator. That means you need to break this down on your own with steps clearly shown in your working. In your exam paper, there will be questions like this where they would want you to break this down without using your calculators. For example, I'll do workings for H and L. So over here we have 1296 with a power of 3 by 4. Okay, 1296 with a power of 3 by 4. Okay, now 3 by 4 represents it has a power of 1 by 4 with a cube involved with it. So we can write 196 with a power of 1 by 4 with 3, which can be further broken down as 1296 1 by 4 with a power of 3. Now, without using a calculator, they do not actually mean that you need to do your multiplications on the rough work, just like we did in the preschool, right? You can obviously use a calculator for this step, but they just want you to have a detailed step for this working so they can give you marks for these easy questions. For example, now you can use a calculator and find out that what is the value for root 1296. Can anyone tell me what is the value for 4 root 1296? What is the value for 4 root 1296?
144.
Nah, the answer should be 6. Do the calculations on your calculator like this. Just, oh, maybe you did the entire working in one room,
Hmm.
one room, right?
Yeah.
No, it's still the answer is 260. Just do this on your calculator. What is the value for root 4
6.
12? Yes, the answer is 6. Vicky, did you got 6 as your answer?
হ্যাঁ পেয়েছি।
So now we have 6 and again as a power of 3. So when you cube root 6, sorry, when you cube the value of 6, what is the value?
216.
1216. So 216 is the final answer. Okay, similar to this, we have another fraction, which is question L over here. 343 and 512 with a power of minus 2 by 3. So 343, 5112. 2 over 3. So as the overall fraction has a whole power, it indicates that both the numbers will have the power. Now, 2 over 3 indicates that it has a power of 1 by 3 and again a square. Right, so we can just keep this as a fraction and just simplify the powers at first. So I'm keeping the 1 by 3 with minus 2, which is cube root of 343 and divided it with cube root of 512. Further, it has a power of minus 2. So when you do just the cube root of 3, okay, just cube root of 343, you get 7 at the numerator. And when you do cube root of 512, you get 8 at the denominator, both with a power of minus 2. So you can finally write 7 power minus 2, 8 power minus 2, which can be further broken down as 1 over 7 power 2 with 1 over 8 power 2. Good. So you can simply break this down as 1 over 7 square with 8 square over 1, which is basically 8 square by 7 square. The entire fraction is now totally inverted. So which is 8 square by 7 square. Now you can write 64 over 49. This is the final answer. Any question for the question N?
No আপু।
Okay, so we'll move to the next questions, I guess. This time we are supposed to solve one for me. Um, which one? Can you please solve 2i for me? 2i. Yeah, both are correct. So we'll move to question 3. For question 3, G, E, and H. This is similar to the one we did in 1A, so I'm not involving in that. Let's do with, no, I think C is the one most trickiest one over here. C or F. Okay, I'll do F for you. You guys will do C for me. So 4 over 9 x power 4 with a power of 3 by 2. Just do this over here. This is question 3. If 4, 9 x power 4 with a whole power of 3 by 2, which indicates we have a power of root and 3. So which is root 4, root 9, and root x power 4, an entire thing with a cube. You get 2x squared over 3, an entire thing with a cube. So when you do 2 cube, you get 8, x power 6, 3 cube, you get 27. This is the final answer. I think all the other 4 questions from 2D is quite easy. We'll move to question 5. It's quite tricky to keep your answer in terms of Y and alphabets. So we'll move to question 5. Given that the value for y is 1 over 8x cubed, now we need to express each of the following in the form of kx power n, where k and n are constants. So the first we have y equals to 1 over 3. Remember, the value of y itself was 1 over 8x power 3. Now, with that, you have a whole power of 1 by 3. Okay, so 1 over 8x cubed. Question 5. Y equals to 1 over 8x cubed. This is a value for 8. In part A, they want you to find the value of 1 over y, 1 over 3 for y, okay, cube root of y. So we can write this as 1 over 8x cubed with a whole power of 1 over 3, which means that 1 over 8 will be under a cube root multiplied with cube root of x cubed, which is basically 1 over 2 multiplied with x. You can write your answer as half x or x by 2. I think keep your answer in half x because your answer should be in the format as kx power n, right? So in this format, k is half, n is 1 because you have x power 1. So now you got k equals to half and n equals to 1. This was quite easy for part A. We will move to part B. We have half y x power minus 2. So for part B, half y power minus 2. So we just put the half at the front before we involve it with the numerical values of y. On y, we have 1 over 8 x squared with the power of minus 2, which is 1 over 2. Minus 2 indicates that it is a power for both 1 by 8 and x power 2, right? So you get 1 by 8 with the power of minus 2 and x squared with the power of minus 2, which is basically 1 by 8, 1 by 2. When you do the calculations for 1 by 8 with with the power of minus 2, you actually get 64 because this is the reason. 1 by 8 with minus 2, 1 becomes 1, but at the denominator you get 1 over 64. And now you have to invert the denominator and it will be eventually just 64. So we get 64 over here and x power minus 4. Go subtract, simplify this and make 32, make it 32. So 32 x power minus 4. You can keep your answer in this format or in fraction format, which is basically 32 x power 4. Is there any problem for question number 5?
আপু
হ্যাঁ,
1/8 x কিউব হবে।
cube ছিল ওটা?
হুম,
Oh, okay, sorry. Cube, হ্যাঁ, sorry. I made a mistake. It was cube for the entire time, so it will be power 6, right? 32 divided by x power 6. Okay, so if there is no problem, then I'm going to end the class over here. We completed for P1 up to exercise 1D. We still have two sections left. Okay. We'll complete that within the next upcoming classes. Now let's with the routine. Let's come with the routine. For the routine, we have our classes on. Yeah. On Wednesday, Friday, and on Saturday from 10:30 to 11:30. We start at 10:30, might not exactly end at 11:30, might end at 12 at some point on some days. Okay. So our classes will be on Wednesday, Friday, and on Saturday at 10:30 to 11:30 p.m. Now, obviously, on Friday, some people might not want to have a class on Friday, but for the month of October, I'm quite busy for my October candidates. So, just for the sake of the first month, we actually have to do our classes on Friday. And if Friday is a problematic for both of you, then we can change this time to weekly days after the month of October. Now, this was a trial class since none of you confirmed for this class. So, this is the class routine, and this is in generalized way how I'm going to conduct the every classes. So, if you guys, like understand my teaching styles or if you think these classes are worth it, then you can join the classes from the first week of October. Okay. Another thing, all these PDFs will be given to you separately in your WhatsApp since you guys are not a part of the classroom yet. But once you're part of the classroom, we'll upload everything inside the classroom and you can get every course PDF and class slides or worksheets or formula sheets directly from the classroom over here. And another thing that all our class recordings will be uploaded in my YouTube, not in the edXL Easy one. It's on the my private YouTube channel. Um, all these videos are listed in unlisted sections. So you can actually like no one can get to these video listings unless they have the link for this playlist. Okay, so we'll share the playlist in the classroom so that you guys can reach to this playlist every time you need to after the class or when you want to review any topic. Is there any question that you guys want to ask before we end class ends?
Okay.
Okay, I think you guys are already tired. I know I extended the class a little bit longer.